All right, in this video, we're going to work on page 4 of the study guide. 14, 15, 16, and 17. It's solve using any method you can. So I'm going to jump right into number 14 here. And number 14 is nice because it's factored and it's already equal to 0. I love both of those. So what I'm going to do is look at setting every one of my factors equal to 0 and solving. And what I just did is I basically, I'm a big fan of color coding things, but basically by color coding it, I can set each one of these pieces equal to 0 and solve for whatever each one of these factors gives me. So in the first problem, I'm going to divide both sides by 4 over 3. 0 divided by 4 over 3 is still 0. So x squared equals 0. If I take the square root of both sides, I'm going to get x equals 0. Second equation, I'm going to subtract 3 from both sides. So 2x equals -3. Divide by 2. I'm lazy, so I'm just going to leave it as x equals -3/2. I do not need to get the decimal version of that answer. And x equals 5 in the last one. So my three answers for problem number 14 would be 0, -3/2, and a +5. All right, so that's number 14. Again, it was already factored and set equal to 0, which makes that a really nice problem to work with. Number 15 isn't factored. It's not set equal to 0, so okay. Let's start by getting it set equal to 0. So it doesn't really matter which side you work with, but I'm going to go ahead and subtract 8x and subtract 12 to make the right side equal 0. So 2x cubed plus 3x squared minus 8x minus 12. There's no like terms there. Now I have a 4-term polynomial here that I am going to factor by grouping. The first two terms have an x squared in common, leaving behind 2x plus 3. The second two terms have a -4 in common, leaving behind 2x plus 3, which should look familiar. This parenthesis set has to match that parenthesis set to make the factor by grouping work. So we're going to take out that common factor of 2x plus 3, leaves behind x squared minus 4 equal to 0. But now x squared minus 4 can be further factored. It's a difference of perfect squares. So x minus 2x plus 2 equals 0. Now I can take this factor, set it equal to 0. I can take this factor, set it equal to 0, and take this factor and set it equal to 0. So each one of those becomes its own equation, and each one of them is going to give me a 0. So let's see, subtract 3, divide by 2, so x equals -3/2. I'm going to add 2 here. Whoops. That's x equals 2. Subtract 2 here, x equals -2. So to fit with my lazy streak, I'm just going to go ahead and box up all 3 of those answers. So number 15 is now done. We had to set it equal to 0 first, factor by grouping, factor the difference of perfect squares here further, and then once it's all factored, set each factor equal to 0 and solve. All right, let's slide on down to 16. Solve the equation using any method. All right, so it's set equal to 0, which is nice. I would like to factor this. So I'm going to factor out a common GCF of 2x. So it's going to be x squared minus 16 equals 0. X squared minus 16 is that difference of perfect squares again. So I'm going to go ahead and further factor that into x minus 4 and x plus 4. Now I'm going to take each factor, set it equal to 0, and see what kind of zeros I get. 0 divided by 2 is 0. I'm going to add 4 to both sides, so x equals 4. Subtract 4, I get x equals -4. And there are my 3 answers to number 16, 0, 4, and -4. You could also write this answer, I'll show you the ultimately lazy way to write it, x equals 0, and then you can put plus minus 4. Means the same thing as a +4 and a -4. It's just a lazy way to write it, I guess. All right, sliding over to number 17 here. Solve the equation. I would like to make it equal to 0. I'm going to go ahead and add 3x cubed to both sides. But I also know that that's not like to anything. So 3x cubed minus 27x squared plus 60x equals 0. I am going to take a wild stab and say that I'm going to take out a GCF of 3x here. So x squared minus 9x plus 20 equals 0. And I'm going to look to see that this trinomial can be further factored. So I want to multiply to positive 20 and add up to negative 9. So the only way I can make that happen is if I do x minus 4, x plus, nope, I lied. X minus 5. So let me double check. Negative 4 times negative 5 is 20. Negative 4 minus 5 is negative 9. All right, I've got my three factors. So 3x equals 0, x minus 4 equals 0, x minus 5 equals 0. So x equals 0, x equals positive 4, and x equals positive 5. All right, so a little bit of practice with solving and factoring there for 14, 15, 16, and 17. Let's go ahead and slide on down to 18. All right, 18 through 21 are all going to be work problems. So let's see if we can set these up and solve them. All right, so we've got Adam working with Dan to create a total here. All right, working alone, Adam can harvest a field in 16 hours. Dan can harvest the same field in 13 hours. How long would it take them if they worked together? All right, so working together, they're going to harvest one field, and we don't know how long it's going to take them. So we're going to have x over 16 plus x over 13 equals 1. I don't have any domain restrictions here because my two denominators are numeric. What I do have, though, is I need an LCD. And if I think about my LCD, it's going to be the two factors or the denominators I currently have, which have no common factors. So 16 times 13, I don't happen to know what that is off the top of my head, but my calculator is going to tell me that's 208. All right, so I'm going to take every single piece of this problem and multiply it times 208. All right, so if I take 208 divided by 16, I'm going to get 13 here. So it's going to be 13x. If I take 208 divided by 13, that's going to be 16, so 16x. And 208 times 1 is, well, 208. 13 plus 16 should be 29, so 29x equals 208 divided by 29. So x equals, let's see, 208 divided by 29, and I am working with a calculator sitting right next to me, so 7.1, I'm going to round off to two decimal places, so 7.17, and I'm checking for my units, this is hours. All right, so if Adam and Dan work together to harvest a field, it would only take them 7.17 hours compared to Adam working by himself for 16 hours and Dan working by himself for 13 hours. So working together, this time together is always going to be less than either person working by themselves if they are not trying to complete some additional number of tasks. So if I had asked how long would it take them to work to complete 5 fields, then it would be slightly different. All right, so just be aware of that. All right, I'm gonna slide over to number 19 here. All right, we've got Aaliyah who can clean an attic in 10 hours. Stefan can clean the same attic in 15 hours. Let's see what happens when they work together. So Aaliyah is one attic in 10 hours. Stefan is one attic in 15 hours. How long would it take them to work together? So one attic, I have no idea for their times. So each one of them gets an x. So x over 10 plus x over 15 equals 1. In this case, there is no domain restrictions to worry about. The denominators are not variables. Your LCD. The LCD in this case is going to be the number 30. 30 is the smallest number that can be divided by both 10 and 15. You, of course, could just say, well, I'm going to take 10 times 15 like I did in number 18 to get that LCD, and you could, of course, work with 150. The numbers would just be a little bit bigger, all right? I'm going to go ahead and work with the smallest LCD I can because, well, I'm lazy, and working with smaller numbers makes me happy. All right, so let's see. 10 divides into 30 3 times. So this is going to be 3x. Plus 15 goes into 30 2 times. So 2x. 1 times 30 is 30. So 3x plus 2x makes 5x equals 30. Divide both sides by 5. In this case, it's going to work out completely perfectly. No decimals. 30 divided by 5 is 6. And I think we're talking about hours here. All right. So problem number 19, if the two people work together to clean one attic, it would only take them 6 hours of time. All right, down to number 20 here. All right, Allie can make 2 hot cocoa bombs in 5 minutes. So we've got Allie here plus Cartier equals, okay, total. All right, let me get this all together. So Allie can make 2 hot cocoa bombs in 5 minutes. Cartier can make 4 hot cocoa bombs in 9 minutes. Now this is where it's going to get a little bit weird because Allie's going to get some extra time. Allie works by herself for 25 minutes and is then joined by Cartier. So plus the time, Cartier only gets X, okay? And they're going to make a total of 144 hot cocoa bombs. All right. So what's going on here? We've got Allie's rate of 2 hot cocoa bombs in 5 minutes. Cartier can do 4 in 9 minutes. Now, time-wise, Allie's going to work by herself for 25 minutes. So that's the extra 25 here. And then she's going to be joined by Cartier. Then we've got the X plus X. So X here is Cartier's time working, and Allie gets that time as well, plus the 25 minutes she worked by herself. So they're going to work together to make a total of 144 hot cocoa bombs. All right, so this one, if I clean this up, I'm going to multiply out. So we've got 2 times 25 plus X. So that's going to be 50 plus 2X over 5. Plus, oh, I forgot my plus sign there. So plus 4x over 9 equals 144. All right. So if I look at this for my, again, no domain restrictions because my denominators are numeric. So I don't have to worry about that. If I talk about my LCD, it's going to be 9 times 5. So my LCD is going to be 45. So I'm going to go ahead and multiply every piece here by 45. All right, so 5 goes into 45 9 times. So I'm going to have 9 times 50 plus 2x. 9 goes into 45 5 times. So this is going to be plus 5 times 4x. And then whatever 45 times 144 is. There's nothing there to divide by. All right, I'm going to distribute. I am using my calculator for reference here. So 9 times 50 is 450. 9 times 2x is going to be 18x. 5 times 4x is 20x. And I have no idea what 45 times 144 is. Let's see, 6,480. I'm going to do 2 things here. I'm going to subtract 450 from both sides. And simultaneously, I'm going to add my 2 like terms here. So 18x plus 20x is 38x. And then if I subtract 450, I'm going to get 6030. So 6,030. Divide both sides by 38. I'm going to also slide this over here. So x is equal to, if I take 6,030 divided by 38, I'm going to get some nasty decimal here. All right, so we're going to go 158.68. And this is minutes. All right. You don't need to convert this to anything else, just whatever your units are, keep them in the same unit. So this was in minutes, we'll keep it in minutes. And this is an example where you might look at it and say, wait a minute, working together didn't save them any time. In fact, they're, so much more time. They're also making 144 hot cocoa bombs. Allie, remember, was in terms of 2 and Cartier was in terms of 4. 2 and 4 are way different values than making 144 of these things. So this one does make sense in terms of our values. All right, one more problem for this video, and that's going to be problem number 21 here. All right, so we've got Mario, and we have Nikki. And this one's going to be a little bit weird, all right, because we're not given their times separately. We're told how much time it takes them to build 2 snow forts. So let's start with that part. Okay, if they work together, he's going to get 45 minutes. She's going to get, 45 minutes. And together, they're going to make 2 snow forts. Now, Mario needs twice the time Nikki needs to build a snow fort. So I have no idea how much time Nikki needs. Let's say I call it 1 over x. I don't know. It's 1 snow fort in some amount of time. But I know Mario needs twice that time. So Mario is going to build 1 snow fort in 2x. Whatever amount of time Nikki needs, Mario needs twice as much. So x for Nikki, 2x for Mario. So if I add those together, let's clean this up. So we've got 45 over 2x plus 45 over x is equal to 2. Now in this case, I do have a domain restriction. My domain restriction is that x cannot equal 0. Now that kind of makes some sense because if you don't give them any amount of time, they're not going to build anything. So that's kind of does make sense. LCD, we're going to look at our 2 denominators. Right now we have 2x here, and then that will take care of this single x as well. So I'm going to go ahead and multiply everything by 2x, 2x, and 2x. All right. So in my first fraction, the 2x and 2x completely divide each other out, leaving just the 45. In my second fraction, the x will divide out the x, leaving 2 times 45. And I'm left on the end here. There's no division here, but it's 2 times 2x. All right, so we've got 45 plus 2 times 45 is 90 equals 4x. So let's see, 45 plus 90 is 135. Yes, it is. I'm verifying that with a calculator just to make sure. Divide both sides by 4. So x is equal to 33.75. Now, what I want to be careful about with this problem is what does x represent here? X represents Nikki's time, okay? Because that's what, we look at the problem, it's x is Nikki's time. I'm asked to find Mario's time to build 1 snow fort. Well, Mario needed twice as much time, so I'm actually going to take x and multiply it times 2. So Mario needs 67.5 minutes to build a snow fort. All right. All right, so that's the end of page 4. We went through 2 types of problems there with solving some different polynomial equations and then setting up and solving rational equations for work problems. Please let me know if you have any questions or concerns. Join Zoom.